left last week. So last week, you guys really didn't learn anything you didn't already know how to do. The only because you know how to graph lines. The only thing new is that now instead of graphing one line at a time, we are graphing two. I am going to introduce you later this week to Wig. You actually use this in real life a lot, especially if you are going to, we talked about that real life example about a break-even point. If you're going to own any kind of business, you really need to know how to solve a system of equations. So remember what your ultimate goal is you're just graphing those two lines and figuring out where they intersect. And then you've got your answer. Now, I'm kind of looked at some of the, I've kind of been watching your all's classwork for, the past week. And these, first of all, are these in slope-intercept form? Are they already in like y equals mx plus b? They're not, right? So that means that you guys have a couple of different options for how you could graph these. You could graph them by intercepts, but what I've noticed is that most of you guys are not graphing by intercepts. You're switching them over. So I'm going to go with the way that I've seen most of you guys doing it to be consistent. So if that's the method y'all prefer, I'm fine with that. So what I mean by that is we are taking the first equation, for example, and we're going to switch it over into slope-intercept form. So I'm going to rewrite it over here. And we want it to look like y equals mx plus b. So what's the first thing that you notice that I need to do to get this to look more like that? Move the x, exactly. The x is over here on the right-hand side in slope-intercept form, and the x is not on the right-hand side yet. So we are going to move that x over to the other side. What do I do to get rid of an x? What takes off an x to get it off that side and put it on the other side? A minus x. So this is, we're graphing two at once. Woo! Double the fun. You don't look impressed. That's okay. All right. So when you move the x over to the other side, this is the number one mistake I saw you guys making last week. That x is not a positive x when you move it over to the other side. To get it to the other side, you've got to switch the sign, because what you're really doing is subtracting x from both sides. That's how you're getting it over there. So if I bring down my 3y, why am I not going to do this? Say 3 minus an x is 2 x's. Why can't I do that? One's an x and one is not an x, so you cannot combine them if they are not like terms. So I'm going to write them as two separate parts, and because slope-intercept form typically has the x in the front, even though it's not wrong for me to say negative 3 minus x, but that's just not the normal order we write it in. Usually the x comes first, and then the number is going to come second. So is there anybody that this isn't jogging your memory? Anybody not sure where I got that from? Okay, so now this still isn't in slope-intercept form yet because I got to get rid of the 3. Yes, sir. Yeah. Thank you. And thank you for not saying minus 3, because that is not how we are going to get rid of that. We are going to divide everything by 3. Let me get a color that's actually going to show up here. And so my y is now isolated. I like where your head was at, Xavier, because you're right. There's technically a 1 in front of that x. So what is the slope? It's negative 1 over 3. Okay, because there's technically a 1 in front of that x. We do not need to simplify this at all because it's already simplified. 1 over 3 is as simple as it's going to get. Don't forget that there is a negative there, though. Also, don't forget about your x. And finally, if I do negative 3 divided by positive 3, that is going to be a minus 1. So now I've got it in y equals mx plus b. So where's my first dot going to go on the graph? Negative 1. So like right here? No, that's the x-axis. Where does it need to go? It needs to go on the y-axis. I don't know what that was, but okay. So -1. Now my slope, my rise over my run is a -3. So that means that I am going to go down 1. And I know we always say over 3, but over could be 2 different directions. So make sure we're not doing this. So I went down 1 and then to the left, because if I go down and to the left, 2 negatives are gonna make it a positive. So that is incorrect. I have to go down and to the right, right there. And then according to every math teacher in America, if you are graphing a line, how many coordinates do you need? 3. I don't have room to go down and over again, but that's cool. I can go back here, bless you. And I can go up and to the left. And if I go positive, which is up, and negative, which is left, that is still going to get me that negative slope. So let me add my 3rd dot. And remember, I know it probably seemed like I was being petty when I said make your line go all the way across the graph. But now you're getting ready to understand why we need to do that. Because now that we're graphing 2 lines at once, if you don't go all the way across the graph, you might miss out on the right answer. Because in a second, we're going to try to see where are these guys going to intersect with each other? Where are they going to cross? And if you don't make your line go all the way across, you might miss where they cross. Okay, so, I know you're like, oh my gosh, am I done yet? Nope, I'm sure not. Because I'm graphing a system, which a system is more than one equation at a time. So that means I'm going to bring the 2nd equation down. I'm now going to switch that one over into slope-intercept form. I made this a little too long. It's kind of in my way. Scoot. There we go. Okay, so how am I going to get the x over to the other side? Minus x, thank you. It cannot hurt to keep repeating it. Okay, so I'm going to do exactly what I just did in the first example, and I'm going to rewrite the right-hand side. So it's minus x minus 3 as 2 separate parts. I'm going to bring down that -3y. And you guys know by now you are going to divide. Lots of negatives here that you could make a mistake with, though, so please be careful. So I've got y equals, what's my slope for this one? +1/3. Thank you. Yes, because there is a -1 hidden in front of that negative x. And a negative divided by a negative is going to make that a positive. And for the same reason, -3 divided by -3, that is also going to be 2 negatives divided to make a +1. So it's more or less pretty much the same equation, just with the signs flipped. B, there's my beginning point. So instead of graphing -1, I'm now going to graph a +1. And instead of going down and then to the right 3, for my positive slope, I'm going to go up and to the right 3. And then I don't have room to go up, so I'm going to have to go back here. If I go down and to the left again, look, I got a coordinate right there. So where are these guys getting ready to intersect?
-3, 0.
Yep. Please do not break my heart and do when we get to our mastery on lines and do all this flip and work and do it correctly and then not get all of your credit because you forgot the one. Like, what was the whole point, pun intended, of doing it? To find this spot right there. Yep. The whole point is doing all that work for that guy right there. So if you don't have -3, 0 written on your paper, you just did all that work and you're not going to get all your credit. So pretty please don't be that person. So this is an example of a system that has what we call one solution. Because if you graph them, They're going to intersect in one spot. We can't keep it simple like that, though, do we? Because we're in big kid math, and so we got to always make it just a little bit more complicated. Not every system of equations has one solution. Some of them got more than that. Some of them have less than that. So let's look at example number 3. So example number 3, I already gave you one of them in slope-intercept form. Go ahead and switch over the second one real quick, please, and thank you. So the first one's already in slope-intercept form, so I'll graph that one in a second. But you guys take a minute and take that bottom one and switch it over. I'll give you a second to do that. Great, thank you. All right, so how do I switch it over? How do I get that X over to the other side? We have seen this movie many times. How do you get it over there? Move it with a minus X. Okay, and I should have lined this up a little bit better. My apologies, guys, because this is going to look a little goofy. So over on the right-hand side, I can't put the X and the 2 together, so I'm going to write them as 2 separate terms. And when I bring down this Y, make sure that you don't leave off the negative. So what is technically sitting there in front of that Y? Is the Y isolated? Can I go ahead and start graphing? No, I cannot, because there is a negative 1 there that we do need to still eliminate by dividing everything by negative 1. So we got Y equals X plus 2. So I just switched this equation over, and you notice anything weird? They're the same. Okay, it's exactly the same line as the one that's up there in the original problem after I graphed it. So it's exactly the same line. So my B, my beginning point, is a positive 2. And then what's my slope? My slope is what is my slope? I don't see a number there, ruh-roh. There's a 1, which means it's gonna be up 1 and to the right 1. Okay, but I've got 2 lines that I need to graph.
Wait, wouldn't that be a negative Y?
Wouldn't what be a negative Y?
The second one, because there's a negative right in front of it.
Yes, and that's why when I switched it over, that's why I divided everything. No, I'm glad. Girl, there's a chance I could have screwed up. You just didn't catch me this time. But so no, thank you for speaking up. Okay, so I got a problem because I've got exactly the same line. So guys, what that would look like is it would look like this. It's basically 2 lines that are stacked on top of each other. What do you think, what's the solution to 2 lines that are the exact same line graphed on top of each other? Oh, I heard it in there somewhere. Yes. How many places do they overlap? Literally everywhere, right? And those arrows tell you that they keep going on forever and ever and ever. So if they're exactly the same equation, what you would say is there is an infinite number of solutions. Because if you lay those two equations on top of each other, they will intersect in an infinite number of places. The big kid word for that almost nobody ever uses, but I can't promise you won't see it sometime. It's called coincident. It looks like the word coincident. So that's the big kid word of saying they're just 2 lines that are graphed on top of each other. Coincident just means it's a coincidence. They're literally exactly the same 2 on top. Okay, so if I did one with 1 solution, I've got one with an infinite number of solutions. What's your logic? What's your guess? What's the next one going to have going on with it? No solution. Yes, so we've got 1. We got too many. And I'll just go ahead. Spoiler alert. Is anybody not okay if I zoom in on number 4? You're good. Spoiler alert. Example 4 is going to be an example of no solution. Now, converting the second one isn't too terrible because there's only one step for this one. Because you just have to divide everything by 3. The x actually already happens to be on the correct side. So y equals, what's my slope if I do 6 divided by 3? So 2, yep. 2x minus 2. So what do you notice this time about the 2 equations? We've got this one and that one.
Shouldn't that be a negative 6?
What should be a negative 6?
On 3y.
Oh, because, are you talking about, because, oh, this was one of the, see how the x was actually on the right side this time to start? So we didn't have to move it over. It's a great question. I'll bet you weren't the only one that had that same question. If it had started out over here, then yes, I would have needed to flip the sign. But yeah, they gave me mostly slope-intercept form already, so there wasn't like too much to do. What do you guys know about lines that have the same slope? They're parallel to each other. So if I've got 2 parallel lines, so let me do the first one first. So 2x plus 3. Well, we're going to cross up here at 3. That's our beginning point. Go up 2 over 1. So I've got one line. So this is my 2x plus 3. And then if I graph 2x minus 2, are those 2 lines ever going to intersect if they're parallel? No. So what did I already say? This is going to be, spoiler, this is going to be a no. Yeah, so if they have the same slope, but they can't have the same y-intercept, because if they have the same slope and y-intercept, they're literally the same equation, right? So this one would be no solution, because they are never going to intersect with one another. And there's no fancy name for that. And if this were a mastery, if you see if they give you 2 equations and you notice they have the same slope, guess what? I will not mark you wrong. If you don't graph it, that's fine with me, okay? Because that means you really actually understand even better than somebody that has to graph it. So if you see that the 2 lines have the same slope and you just say, oh, I already know it's no solution, I'm fine with that. That is working smarter, not harder. Because if you know that they have the same slope and know that there's no solution, good for you. Okay, example 5 is actually very similar to the ones we've already done, so I'm not going to do another one because I feel like looking from what you guys have, like y'all kind of have the gist of this a little bit, I think. Now, there are a lot of places that you can go wrong, of course. Flipping it, switching it over into slope-intercept form, making sure you graph it correctly and all of that. So you do have a Delta Math assignment, but I gave you I set it up for today for you to have 3 chances for each one before you have to try a different problem. Because there are like a lot of places you could goof. You could accidentally mess up when you switch it over. You could accidentally graph your slope backwards. So there's